All right, so the big topic, the big thing we're kind of talking about this topic, okay, for this section is we know that triangles have three sides, three angles, and those three angles are always going to add up to 180 degrees every, let me just do this, every single time. Triangles, you can't have three sides, you can't have a triangle unless it's got three sides, three angles. That's just a fact, and you guys know that, right? The same kind of facts, the same kind of logic suggests and say that every triangle also adds up to 180 degrees. So every angle, if you added it up, always adds to 180. But what's so kind of special and unique, okay, and I'm going to draw this twice. I'm going to draw it in different ways, okay, just so you guys can kind of see some examples, because you might see it written differently on your test, or you might see it in one of these methods. But if every angle on the outside, okay, shoot, now I'm being silly. All right, so let me do this. So every angle, so if I call this 1, 2, and 3, if I were to add all three of those, if I was to add all three of those angles, angle 1 plus angle 2 plus angle 3, they always add to 180 degrees. So 60, 60, 60, okay? 45, 45, 90, 30, 60, 90. All three numbers should add up to 180 degrees. Also, if you have a line and any angle coming out of that line, okay, and I call this, let's say, 4 and 5, angle 4 plus angle 5, those also add to 180. That was kind of like last semester, some of the last topics we talked about, is having a straight line with that, and two angles create a straight line, right? And so they also add to 180. So it sounds like it's the same thing, but one has three parts and one has two parts. Okay, triangle's got three angles, two that add to 180. This has two parts that add to 180. So it's like they don't seem like they have a lot of things in common. They just both happen to add to 180. That's kind of the end of the, well, there's other fun things we can talk about with this, but this is kind of the basics, okay, is that triangle, three sides, three angles, all angles add to 180. Straight line, you put a line through there. Those two angles add to 180, okay? It's a lot of times you'll see it written like that. It's like a half circle, right? Okay. So if I was to do something like this, let's say 1, 2, 3, and 4, okay, we can look at this in different ways. We can look at this as those add to 180, okay? So if you're given like the outside angle, you can always find, or that's called an exterior angle. The interior angle there, a little pair will add to 180, okay? They form a little thing there, okay? I know angle 1 plus angle 2 will equal to 180. Just like the 2, 3, and 4 would add up to 180 as well, okay? The same would go true to something like this, okay? If I said 1, 2, 3, and 4, okay? That 3 plus angle 4 would add up to 180. Okay, and that also would say here that 2, 3, and 4 those add up to 180. Okay, and then 1, 2, and 3 for this problem would add up to 180. It's so much 180, it's so crazy, okay? And I'm going over this slowly, and I'm repeating myself 3, 4, 5 times because there's one thing that's going to come out of this that I really want you guys to understand. And let's take a look at this little guy right here. I've got angle 1 plus angle 2 equals to 180. And I know angle 2 plus, I know I'm rewriting it a million times, but follow me here. Okay, it's that math teacher thing, right? Write the same thing a million times. So if I know these facts, right? If I know these two facts, that every triangle has 3 sides, 3 angles, all the angles add to 180. Every time you have a straight line with angles, the whole straight line would add up to 180. So here's some knowledge, right? If these both equal to 180, doesn't that mean that angle 1 plus angle 2 has to equal angle 2 plus angle 3 plus angle 4? If they both equal to 180, that says that this has to equal that. Okay, that was transitive property, if you remember that. You have the A equals to B, B equals to C, therefore A equals to C. Like the first thing equals a second thing, the second thing equals a third thing, therefore the first and third thing are equal. Now that's cool, Mr. Atterbury. That's just a big mess, right? Well, for this particular problem, this is all related to these angles right here, okay? If I was to do some algebra and subtract angle 2 from both sides, you're like, what? I know, this is awesome, right? What I get is angle 1 has to be equal to angles 3 and 4. So how it's labeled is arbitrary, meaning it doesn't really matter, okay, how it's labeled. It could have been called angle A, B, and C or whatever. Okay, so if we go back to our diagram, I'm going to use a different color. Let's use green. Okay, we got angle 1 is equal to angles 3 plus angles 4. So on our picture, that says this angle is equal to those two angles added together. I know I was telling you guys and showing you guys, I'd say, well, if that equals to 180 and those equal to 180, you take the middle piece out, and so that 1 has to equal those two added together. That's just a basic fact, okay? So that's cool, Mr. Atterbury, but what will that look like on our test, right? Let me show you. So on your test, you're probably going to see a question that looks similar to this. Okay, they'll give you something like A, B, C, and D, and they'll give you some stuff like this. They'll say something like this over here equals like 78 degrees in that little corner right there. And then they'll give you something over here on this piece. And they'll say something like this over here is like 100 and, I don't know, let's say 132 degrees, okay? And they'll have some little marking that the little angle right there, okay? And they'll say, let's say in a problem like this, they'll say something along the lines of solve or find, right, these two angle measurements. They'll say the measure of angle CAB and the measure of angle BCA. So we have not reviewed this yet, but when you're given 3 letters for an angle versus just a number for an angle, okay, all those letters are actually what's called vertex points. They might not draw it in there, but usually they overemphasize it by drawing dots. Okay, those dots aren't really there. Those dots are just kind of markers for where that point is. Okay, to call it a vertex point. But if you follow from left to right, okay, if you follow this and say CAB, CAB, that means CAB, they're looking for that little angle right there. Okay, now you don't got to solve these in any order. You can do BCA first. Doesn't really matter which one you solve for. But look at BCA, BCA, BCA. So it's always that second letter is where like that main little kind of like vertex point is. Okay, but the other letters, the letters around it, help you decide, is it like this inside angle or is it the outside angle? Okay, if it was BCD, it would be the outside angle. Okay, but this one says BCA, so we know it's this little inside angle right there. So make sure you know your notations, please. All right, so there's a few ways you can do this kind of problem. I'm going to show you straight up. Let's use this method I was just showing you right now. That would say measure of angle BAC plus angle of 78 degrees, that's going to equal to this outside angle of 132. Once again, this exterior angle is always going to be equal to what's called these remote interior angles, okay? Those two outside guys. And so if I know two of them, you can always solve for the third one. It's just three pieces there. So then I'm going to subtract 78 to both sides. And I would get the measure of angle BAC is going to be equal to 132 divided by minus 78. So when I do that, it looks like it's going to be what? 54 degrees? Okay, feel free to use a calculator to double check and triple check your work. Okay. Have scratch paper out while you do these tests. Okay, do the best you can as you go through it. And so this would be 54 degrees. And I like writing that in there. Okay, so I recommend writing that stuff down as you go through it. Okay. Now it still says BCA. We're still missing that piece right there. So you have two options. You can either say, well, this plus that is 180, so 78 plus 54 or whatever, plus some missing piece equals to 180. Okay. The alternative is you could say, well, those two added together equal to 180. I'm thinking since that's less pieces of information, it's only two angles versus three angles, it might lead to less mistakes. Okay. And usually I like to try to use strategies that generally lead to less mistakes. So the fewer pieces you use, from my personal experience, it usually leads to fewer mistakes. So I'm going to look at this and I'm going to say BCA. Whoops. BCA plus this 132. Those two angles, because it forms a straight line, are going to add up to 180 degrees. Solving this, I'm going to subtract the 132 to both sides. And I get the measure of angle BCA. See, we're already done. 180 minus 132, I get 48. Okay, feel free, once again, use a calculator. And then you can always double check. I recommend double checking with your calculator, especially 48, 78, and 54. Add those three up. Okay, and that should be 180. Okay. So I'm going to pause for a moment. And before I move on, so now, oh, this problem as well, you could be using algebra. So make sure you understand all your algebra techniques as well. So I'm going through right now, and that's pretty much most of the stuff for this kind of topic. I'm going to do one more question like this, but I'm not going to review a lot of the algebra. Okay, I'm simply not going to. If you need help with the algebra, please come to tutoring, or we can review that on Friday. But I think I've reviewed enough at this point. I'm not going to not review it. I'm just not going to review it today. I want to focus on the geometry concepts, okay? All right. So there's one more thing using this kind of strategy that's outside of the algebra type work, and let's take a look at that. Okay. Let's take a look at what that will appear as. Okay, and that's that one that looks like this. It's got a triangle, just similar to the other ones. Okay, and what they do is they do all these exterior angles. Okay, they make a line like this. They make some sort of line like that, and then they do some sort of line. I don't know, whatever. Okay, it's just these three lines, and those three lines in the middle of a triangle. Okay, and they'll label it something like this. So I'm not going to do any extra notes. I'm just going to show you an example here because the previous notes we just did, talking about the interior exterior angles, it all still holds true. This is just kind of a different style looking question, and it'll say something like this. You guys probably remember this from your work a few weeks ago. It might look something like that. And then this could be something like this. So one thing we actually have not talked about, and I apologize actually thinking about it, is that all these exterior angles, okay, there's 3 exterior angles. All those exterior angles are going to add up to 360 degrees. You can actually do this without doing the 360. But if you want to solve right away for angle 1, okay, you can just simply say that this, and that. So whenever you've got some sort of triangle created by all these angles. Now I heard a little beep, so I'm going to double check real quick. I'm assuming someone's got a question. How do you find X, Clayton? How do you find X? I'm not going to go over that right now. That's one of those things I've gone over a number of times this semester so far. I went over it last semester. It's an algebra concept, and just for the sake of time and to respect everybody's time, I'm just going to stick on geometry topics. Okay, going over reviewing, solving 1-step and 2-step questions. I don't mind doing that. I'm just not going to do it right now during this live session. Okay, I want you guys to do your skills and strategies. If it's one of those things, Clayton, where I see on Friday, everyone just mess those questions up, then I'll spend like 30 minutes or an hour reviewing that on Friday. Okay. If you feel like you really need that attention and that one-on-one tutoring for that stuff, contact Miss G, contact me, let me know, and we can do some tutoring sessions to get those skills brought up. There's a lot of resources out there for you to assist you as well, and I've told you guys about those, and I recommend using those resources. There's a lot of online websites to like help you solve algebra problems. If you can set it up and you can plug it into those algebra calculators, go for it. Okay. Hopefully that'll help you out and put you in the right direction. Okay. All right. So you might see a question look similar to this. Okay. And if we have something like, let's call angle 1, angle 2, angle 3, it doesn't matter anything else. Okay. You got a triangle. It's got 3 angles, 3 sides. But if they extend those legs, if they extend those lines out and create these exterior angles, okay, an angle here, an angle here, okay, and an angle there, those outside angles actually are not 180. I know everything's been 180, 180, 180, 180, like all day, every day. Okay. This time though, because it forms a circle, it's no longer forming like a straight line, but these exterior angles all form a full circle. What you're going to see a theme throughout the rest of this year. If we ever have outside angles of any shape, 3 sides, 4 sides, 5 sides, 100 sides, okay, 360 sides, okay, those outside angles are always going to add up. Whatever they are, they will always add to 360. So if I know that, I can say angle 1 plus, let's say 126, plus, let's say 101, that's going to add up to 360. So I'm going to combine these like terms and say 126 plus 101 is 227. I'm going to subtract, oh, that is still equals 360. So I'm going to subtract that from 360. Take it away, right? And what's left over will just simply be angle 1. And so 360 minus 227 is 133. So that's going to equal to 133 degrees. And then you can bet your bottom dollar they're going to ask for those 3 angles inside. Okay, so this is going to be measure of angle. So I'll call that angle 1, but they're going to also ask for those 3 angles. Let's start with angle A. So CAB or BAC. Let's just call it CAB, but it might be BCA. But they refer to the same angle. CAB or BAC are the same angle. Okay, that angle will be, so what I can do for this one, right, since these add up to 180, I can say this plus this equals to 180. The shortcut was to say 180, take away this 133, because that's how it's going to be solved, and that would be 47. Okay, 47 and 33 add up to 180. Let's do the next one. Let's call it CBA. Okay, 126 plus that angle is going to add up to 180 again. So the shortcut, like I was just mentioning, would say 180, take away the 126, and what's left over is 54. So that would be 54 degrees. And now we've got a few options. Option 1, we can solve any triangle on the inside adds up to 180. I could do the whole fact knowing that 126 is equal to 47 plus that missing angle. But I'm going to keep doing this simple trick of every time you have those little angles next to each other and they form a straight line, they're going to add to 180 every single time. So I can say 180, take away that 101, and that equals 79. Let's call that ACB. Is 79 degrees. So we can verify 79, 47, 54. I'm looking right now, and that appears to add up to 180. Okay, this piece should add to those. This piece should add to those. This piece should add to those. Every little angle pair here is going to add up to 180, 180, 180. Inside 180, outside 360. Okay, that's how these problems work. So I'm going to pause for a moment, and let's take a look at what the next topic will be. Once again, I'm going to upload this video, and I will upload the notes that I'm writing down here. Okay. All right. So next thing we got to cover, we got to do congruent. Okay, congruent triangles, what it means for general congruence, and do a quick recap of special triangles, equilateral and isosceles triangles. So I'm going to go ahead. I'm going to go to, hold on. Yeah, I'll go to a new sheet. So taking a look at congruence, okay? So an equal sign, okay? Equal means same size. So that's like two people that weigh the same. Just because two people weigh the same doesn't mean that they're like twins or anything, right? They don't look the same. They just have the same weight. Similar means that little squiggle line you'll see means the same shape. So that would be like twins, right? Things that look the exact same. So if you got a small square and a big square, okay, those are the same shape. If you've got one of my favorite examples are like model cars or model like planes or model helicopters. They're all appropriate scales, right? They all look like the same exact shape of what it's supposed to be. It's just a little like a little a little small miniature version of what it's supposed to be. Okay, they'd be considered similar because they look the same. All the angles are the same. Okay, all the shapes just look exactly the same. So if they have the same shape and they're equal in size, I mean all the side lengths are the same, everything's the same, right? So this is kind of like the angles. This is kind of like the side lengths. If those things are both the same, we call that congruent. Okay. Congruent means same shape and size. So you stack an equal sign with a similar sign, okay? You put a little squiggle on top of an equal sign, and they call that congruent, okay? And that means they're the same shape and same size. So you're going to see a few things. The first thing we're going to look at is, let's say we have A, B, C, D is congruent to W, X, Y, Z. And when they write something like this, they don't do it by accident. And what I mean by that is whatever A is, it's the same thing as W. Whatever B is, well, that's the same thing as X. Whatever C is, well, that's the same thing as Y. And whatever D is, it's the same thing as Z. They're literally the same thing. They're just twins. It's like his ear is equal to his ear. His nose is equal to his nose. His eye is equal to his eye. And it's all in the same exact order. You won't see this mixed up. It's always the first thing here, the first thing here, the second thing here, the second thing here. And they're always in the same spot. And so you might see some weird stuff that looks like, let's say something maybe like, let's say like that. And they'll call this A, B, C, D. Okay. And then they'll draw some sort of shape next to it. Okay. And it might not look the same. It might look like it's all kind of like twisted up and around. And I'll show you my strategy of what I like to do. Okay, and I'll do something like this, and it says W, X, Y, Z. So it might look like this, W, X, Y, and Z. And they'll say something like, let's say this is equal to, I don't know, let's say 18, and this equals, let's say, X. And they say solve for X. Now, obviously, this is a little easier than what you're going to see, but I'm doing it just for time, but the same thing kind of applies. And you might ask yourself, well, those are in different spots. I can't really solve for X because I don't have enough information. But what I'm telling you is, let's kind of ignore this for a moment, and I'm going to redraw this picture. Okay, so I recommend highly having like a ruler or something out and trying to draw these kind of shapes that you see on the screen and try to recreate them. So since it said that they're congruent, that means they're all going to be the same. That means you can twist and turn this around and so it looks like the other one. So you see how it says A, B, C, D, and this is W, X, Y, Z. I'm going to do that in the same order here and say W, X, Y, and Z. Okay, and then you see between X and W, it's the letter X. Okay, so that would be like this right there, which makes sense now because look at this. These are in the same exact location. That means I could say, for this case, X would equal to 18 and call it good and be done with my life. Okay, now for your actual test, like your practice we did earlier, they're going to have like 2x plus 3 equals 5x minus 1 or something. You got to solve for x and then plug it back in and all that kind of good jazz. But when you see shapes like this, and here's kind of one of the big test taking tips. If they're saying they're congruent and they give you one piece and one piece, I would just set them equal to each other and make the assumption and move on. Okay. However, the general good strategy, right? Not the shortcut, but the good strategy would be just redraw this shape, whatever you see, exactly how you see it here, and then relabel it how you see it up here in this diagram. And then look at here and say, well, what information did they give me? Oh, well, between X and W, they had the letter X or whatever. So between X and W was the letter X. And just try to like translate what you can between the shapes, right? Yeah. All right. Whew. That's it for the basic congruent stuff. And that's going to lead us to the next section, which is on triangle congruence. And then that will be it for the review. Okay. The triangle congruence, that was the thing. I sing that silly song and I'll sing it again. I'll put it on record again for the millionth time. Side, 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 angle, side, angle, side, angle, 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 side. Okay. So this is the triangle congruence. Okay. Now, I'm going to go ahead and make a little key here and say S is equal to side. A is equal to angle. Okay. So these ones are good. And that is side, 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 angle, side, angle, side, angle, 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 side. Thank you, Miss Hill, Laguna Creek High School, 1996. I still remember that song from her. Okay. So if you have two triangles, okay, if you have two triangles, and they have different ways to mark the notation, I'm going to use the notation that they're going to use on the test, okay? So if you see something like this, okay, this is A, B, C, D, E, F, I could say that ABC is congruent to DEF. How do I know that? Because of side, side, side. They have all the same three sides. You know, I'm going to do this instead. So what you might see is something like this. This is congruent to this. This is congruent to that. Okay, so side, side, side. Let's do side, angle, side. So what if instead it looks a little bit different? Okay. So what if instead we had ABC D, E, F, and they said side, angle, side, side, angle, side. So one thing I kind of forgot to slightly mention here is what I mean by the side, 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 side angle, side, all this kind of stuff. What I actually mean by that is if we know that those three pieces are the same in that exact order, okay, that side, angle, side, right? Side, angle, side. What that means is the rest of the triangle is the same also, okay? If you have three sides that are the same, that forces the three angles to be the same. If you have a side angle side equal to some other triangle side angle side in that same order, that means the other angles are the same also. That A and D would be the same. C and F would be the same. Okay. This length down here would be that length down there also. Okay. That's what it means by, if you just know that, that means the rest is the same also. So that can give you a lot of cool information that you can probably use for something else, right? So let's do angle side angle. So angle, side, angle. You can imagine angle, side, angle, angle, side, angle. Let's keep it consistent. Once again, you've got angle, side, angle. So you've got two angles with the side in the middle are the same. So that angle is the same as those angles are the same, sides are the same, angles are the same. If that's true, the rest of the triangle is the same too. Okay, that is triangle congruence. And that leads us to our last one, which is going to be angle, angle, side. Okay. Sorry for running out of space here, folks, but trying to do some neat little notes. So angle, angle, side. Angle, angle, side. So angles are next to each other, the sides on next to them. Angle, angle, side. Now, they don't have to be drawn exactly this way. They can be twisted and turned kind of like the other example we were looking at. Okay. But I could say that, once again, I'll make this statement. ABC is congruent to DEF, and that's going to be angle, angle, side. Okay. So the side's not in the middle of the angles. The side is next to the angles. Okay. Like this has the angle in the middle of the sides. Okay. This has just three sides. So there are a couple other things you might see, and those are considered bad, meaning the triangles might be congruent, but you just simply don't have enough information to make that claim. Does that kind of make sense? Okay. And so the bad ones, okay, so this means if you have two triangles and those those pieces are the same, side, 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 angle, side, angle, or angle, 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 side, then you're good. If you have three angles, angle, 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 that doesn't really tell you anything. Okay, that says they're the same shape, but they're not. But they might not be the same size. Okay, and the same thing with side, side, angle. Okay, you notice here that the sides are always either all three sides or it's the side with the angle in the middle. But if the angle's on the outside, there's a weird thing where there's one special case that this doesn't work, and so they say that just don't use that one. Okay, those are just we just don't know. Okay, so because we don't know for sure, we can't prove it unless we have more information. They say it's not enough for congruence. Okay. Okay. One last thing we're going to go over, a little longer than I wanted to, but I think we're still doing okay. So the last thing we're going to go over are special triangles. Once again, if I'm moving a little too fast, I apologize, but I will post these notes later along with this video that I'm doing right now. Okay, so there's two special triangles we looked at. We'll go more into special triangles here in the near future, but these special kind of triangles, there's a equilateral. Woo. And isosceles, E-L-E-S. Let me double check that. I feel like I'm wrong. Oh my gosh, I'm right. I'm the smartest man alive. Just kidding. I can spell isosceles. All right, so an equilateral triangle, it's exactly kind of what it sounds like, equal, okay? That is where all three sides are the same. And since all three sides are the same and every triangle adds up to 180, there's something special about that where every angle is going to add up to 60 degrees. So it does not matter the size of the triangle. This can be either tiny, like microscopic, or it could be gigantic, like the size of 3 stars, and you want to know like the angle between these 3 star systems, whatever. And it's like, oh shoot, you know what? They form an equilateral triangle. So the degree measurement from this star to this star to that star, they're all going to be 60 degrees. Like what? That's crazy. But they have to be equal distance. Okay. If they are equal distance from each other, equilateral, then all the angles will add up to 60 degrees. That's just one of those special properties. Isosceles, there's a few different definitions for that. But generally speaking, that's the isosceles triangles are the ones that look like this. They're very kind of classical looking triangles. However, the definition I've generally seen, the definition I've usually used in my classes, is this idea where either 2 angles are the same, 2 sides are the same, or all 3 angles are the same. Now, something to note is whenever you have equal sides, you have equal angles like I showed right here, okay? But also what happens, if you have 2 sides of the same, it actually forces these angles here to be the same, okay? But this one's going to be different, okay? If those 2 sides are the same and this one down here is different, that means the angle that creates the different side is going to be different than those 2, okay? So what that would look like on your exam you know, I'm gonna leave it just like that. I'm pretty sure I feel like I've gone over all the general notes. So okay. So here's kind of the big picture here, right? They say 3 sides are the same. This is at least 2 sides are the same. That's kind of the definitions I've always seen. Some people argue that isosceles is only 2. I've always seen it as at least 2, but I've seen online discussions and stuff with professors and teachers and everybody saying like, well, isosceles is 2 and equilateral is 3. So Kaylee says that I'm moving a little too fast. Okay, and I apologize if I'm moving fast. I'm just trying to review a month of work in like 30 minutes so that I'm not reviewing the whole entire time. If I review the whole entire time, it's just simply not going to be enough. Okay, so as far as office hours, Kaylee, I'm letting you know I just picked up a new coaching position. I'm going to be the new boys tennis coach. So you know, let me cut this video off and I'll kind of explain what's happening, but I'm not going to be available Monday, Wednesday, Fridays anymore for tutoring during regular office hours. Okay. I can't make that commitment right now. If I'm going to have to do it, it's going to have to be after like 5 or 6 p.m. in the early evenings. Have to coordinate with your parents and everybody. I know Miss G has a lot of time. She's trying to make time for you guys to do tutoring. I'll be available Tuesdays and Thursdays. Okay. But Monday, Wednesday, Fridays, my schedule right now is pretty much from like 2:30 to 4 o'clock, or you know, it's maybe till 5 o'clock or so. I've got to be down at the school, you know, working with student athletes through their spring season. So if you were one of those players, you'd probably want your coach to be attending all your practices, just like you want me to be here during these classes and stuff. So stopping the